let's import our data. From the File tab to Special Import. From there, I'm going to Browse. I'll be using this dataset, Provisional COVID-19 Death Count. Open. And I have this. So I can delete these 3 variables. I should have done that earlier. Okay, now I have just the data I need. Let me expand it. Okay, good. So firstly, let's perform descriptive analysis. That is, let's have a summary of what we have in this data set. We don't have anything to do with this. There's this, as per the prompts. So we don't need that. So what we need for this analysis are COVID-19 death and the sex as well. So now let's do that analysis, then exploration. Under exploration, following this drop down menu, we'll click on descriptives. Beautiful. So we have all our variables, we have them here. And here I can change it to be perhaps across row or across columns. Depends on how I want it to be. It's still the same thing, but different presentation, different formats. Let me go for the columns rather. And then we have statistics. Here I can select the things I want to see. This is the sample size, the number of samples, the number of entries, same thing, missing values. This is mean, central tendency, the median, the mode, the sum. I can click on them. It will be shown here. So it depends on what I need for my interpretation or what I want to achieve with the data set. And here we have the dispersion, minimum, maximum, variance, range. Then the distribution, this shows how this value gives us an idea of how the data is going to appear on a graph. Then normality shows us whether the data is normally distributed or it is not normally distributed. That is what Shapiro Wilk's tests would tell us. Then outliers, that is when we have values that are very, very extreme. Then we can click on this. We have the standard error of mean, and then we have the confidence level for the mean. So it shows us that if this kind of study is repeated, at least it will be correct. It will be correct at a particular probability, which is, or percentage rather, which is 95%. Let's say there is an error or there is something somewhere, so we are given that 5%, and that is what we call the significance level, 0.05, and that is what we use to determine whether our data is normally distributed, it is not normally distributed. We also use that to determine if the hypothesis, is significant, is statistically significant, or it is not statistically significant. So that is that about the descriptive statistics. Then the plots, these are for graphical representations, histogram, density, box plots. So everything is going to appear on the results page. The QQ plots, volume data, bar plots. So that is that. Now let's do something. These are the variables we have, and according to the prompt, according to the research question, we are to determine if there is a difference or if difference exists between the number of females and the number of males who were victims or who died as a result of COVID-19. Now, this is COVID-19 death. Two variables. Then I can also do it this way, click on sex and then that's so split by sex, that is, I want it to give me the number of COVID-19 deaths according to their sex or according to their gender. So it's split by will tell me, shows that either it's going to give me the number of females, it's going to give me the number of males. So this is the result. So this is the minimum number of females that died. This is the minimum number for female. This is the maximum. This is the for female, maximum for male. The standard deviation shows us the variability that exists across all the number of deaths that were recorded. And then the median, telling us that median, according to graph, it's very close to the mean. So it shows us that this is like the range close to the mean of people that died as a result of COVID-19. We don't normally use it, yeah, but it's still cool. So basically what we use many times in descriptive statistics is the number. This is 87, and also to see whether there is any missing values. It shows us that, okay, truly the data was really cleaned. Yeah. And then we have the mean, that is the average death. I can also click on sum, showing us the total number of people. Yeah. So this is the sum. This is the sum. So we have total number of female that died as a result of COVID-19. We have 511,963. That's 511,963, and this is for the males. So that is that about descriptive statistics. Okay, now distribution, skewness and kurtosis. Okay, so we have positive values. What I mean by positive value is it's positive because there's no negative sign at the front. So that's why it's a positive value. And it means that when this data set appears on a graph, so the distribution of the data will have a long tail, something like a curve, will have a long tail on the positive side of the graph. A graph has four cardinal points, like we have the positive up, negative down for the vertical side, and then by the right we have the positive, left we have the negative. So on the graph it's going to show that we have long tail of that curve on the right side, which is same as the kurtosis. Which is same as the kurtosis. And a little difference between the two is that kurtosis is telling us that for if we have positive kurtosis, that means there is a sharp edge, like the curve is so sharp at some point on the right side. So that is what it means. Then this is Shapiro Wilks. This is used to determine if the data is normally distributed or it is not normally distributed. And like I said earlier, using the significance level, which is 0.05, in this case now, this value is lesser than 0.05. And that tells us that it is not normally distributed. Let's assume the value is greater, the value is greater than 0.05. That means that the data is normally distributed. So, but in this case, this data set is not normally distributed. So that is that for. Let's go to the plots. It's still loading. Okay, so this is the histogram. This is the histogram. This is for females. This is for male. Showing us it's just like having what we have in the table in a graphical representation. That is what we have here. So all of these values are based on the skewness and kurtosis are all on the right side. So this side, negative, negative, and then down, below is also negative. Box plots. Bar plot as well. Still loading. Okay. So this is the box plots. So these 173, 174 are the outliers. I'm waiting for the bar plot to load. Okay. So this is it. Different kinds of graphical representation. So it depends on what the lecturer needs. So that is that for descriptive statistics. So it gives us the summary of what we have in the data set, introduce us to, okay, this is what we have. Then inferential will now lead us into taking conclusion. Okay, so this is what it means. This is the implication of the values that we have here and there. Now I can import this result from here. I can export it rather. So I'll click on export. PDF document, I can title it Descriptives. So I've exported it already.